All right, guys, inverse functions day 2. We did exactly one of these the other day where we had to graph. All right, what was the business with color in the unit circle? Okay, the inverse sine or arc sine has a possibility of answers between what and what? Okay, look on your pink, yes, quadrant 1 and 4, but what did that mean? Negative pi over 2 to pi over 2. This is at the bottom of the pink sheet, right? Okay, cosine, -1, or arc cosine, which are the same thing, had what range of answers? 0 to pi. Okay, tangent was the same as which one? Almost the same as sine. Does anybody remember what was different? Yes. It's from negative pi over 2 to pi over 2, but it can't be either of the ends, okay? It's written in this notation on the bottom of your pink sheet, which is what you will have for the final and the second quiz. But the first quiz, I'll let you use the colored one. All right, so what's the mess with this example up here? Well, there's no 3 pi over, or 3/4 anywhere on my unit circle, right? Okay, so this is how you do this. Everybody ready? You're going to work inside out, and you're going to have to draw. So what quadrant has an inverse tangent that's negative? You look down here. Tangent is red on mine. It's negative in quadrant. Everything's positive in 1, right? Tangent is negative down here. Okay? I drew that really badly, but okay. How am I going to label that triangle if it has a tangent of -3/4? Tangent is opposite over adjacent, or y over x, yes? Which one of those gets a negative? The 3, because it went down, yes? Anybody confused? Okay, if I want the cosine of that triangle, that's all I gotta do is find the cosine. I need to first do Pythagorean theorem to find the hypotenuse. And I get 5, yes? So what is the cosine? What's the cosine? Did I label this wrong? Tangent is y over x, or opposite over adjacent. So cosine should be adjacent over hypotenuse, 4/5. Okay, I'm hearing different things. Are we good or not? Okay. There's going to be some of these where you have to draw. Okay. The other thing that's going to come up, oh, let's practice these two real quick. This is from last week. This says go to pi over 3 and find the sine, not the inverse anything. What is the sine value at pi over 3? So if I go back here, pi over 3, sine, make sure you're doing sine, not cosine. I get square root of 3 over 2, right? Now it says arc cosine. What does that mean? It means find an angle whose cosine is square root of 3 over 2. Which means it's in the x spot, so it's pi over 6, yes? Are we awake and trying this? I'm not hearing a lot of you. Okay, is this one of these? Same thing we just did? On this question, 7a? No, this is what we did on the previous slide, right? Because this is not on my unit circle. Okay, I have to draw. Arctangent is positive, tells me I'm in quadrant 1. Why isn't it 3? Couldn't it be 3? Nothing's in quadrant 3, right? Okay, none of the inverse functions are in quadrant 3. Arctangent is positive in quadrants 1 and 3, or tangent is positive in 1 and 3, so arctangent has to be in 1. All right, how do I label this? Using my little bow tie triangle. This is opposite over adjacent, or y over x. Everybody okay? Pythagorean theorem, anybody know this one? Okay. It wants the sign though. Opposite over hypotenuse, or y over r. Everybody okay? All right. This is the kind you're not going to like. We are going to be given one function, have to make it a ratio, and then have to use Pythagorean theorem with a bunch of letters in it, okay? Before we do that, guys, I need you to be with me that, does that simplify? No. Right? Does that simplify? No, because of the plus, right? It's gluing it all together. The only way that would simplify, and it's not equivalent at all, but if it said that, it would simplify, right? But these 4 plus x squared is not the same as 2 plus x, because it'd have a middle term. That's a whole other thing we do wrong sometimes, right? All right. Just prefacing this because this is what students struggle with. Okay. It says write a tangent, find tangent of arcsine of A as an algebraic expression that does not involve functions. Okay, so they say we're going to draw, okay, this is what we're supposed to be solving. So I look at this and I go, okay, these you're going to just do in the first quadrant unless they give you an, I think they're all first quadrant. So I look at this and I say, this means the sine is A over 1. Everybody okay? That A means A over 1. And sine is opposite over hypotenuse, right? So I draw a triangle. I can use theta, whatever. Opposite over hypotenuse, A over 1. I need an expression down here. So I'm going to call this x for a minute because it's along the x-axis, right? So right now, if I wrote x squared plus a squared equals 1 squared, how could I get the x by itself? 1 squared is still just 1, right? And I would have to subtract the a squared over there and then do what? So the expression I need to write down here is 1 minus a squared. Now it wants the tangent. Tangent is opposite over adjacent, so I'm going to have this over this. All right, they couldn't have made this one any uglier, could they? So we're going to have to multiply by this, which does what to the denominator? Just leaves it 1 minus a squared. The numerator is going to be this times this, okay? They did a lovely example that was about as ugly as it could possibly be. All right. You need this in calc, so we're going to do a few of these, all right? So here's an example. I don't know if you have this one. Do you have 8A on your paper? Okay. So we're going to draw first quadrant. And this means the cosine is what? Yes. The cosine of some angle is x over 1. And cosine is adjacent over hypotenuse, right? So I'm going to put x here and 1 here and the angle here. They use u. They don't use theta just because it's an inverse. It doesn't matter. We need the sine expression for this triangle. All right. if I call this y, we're going to have to write an expression over here that only has 1's and x's in it. But I'd have x squared plus y squared equals 1 squared, which is 1, right? Now what? 1 minus x squared, square root. So that's what's going to go here for y. And I cannot simplify. Everybody okay with that? All right, now how do I write the sign? The sine of the arc cosine of x equals, what's the sine function of this triangle right here? Opposite over hypotenuse is over 1 or just by itself, right? All right, guys, there's one of these on the quiz, so wake up and pay attention. What quadrant do I draw my triangle in? Just in the first quadrant for these, because we don't have to worry about the sine. Okay. X sine is opposite over hypotenuse, so I'm going to put x where? This doesn't feel right, but I'm going to have to put the x there, yes? And the 1 here. Okay. Anybody know the expression yet? Hypotenuse squared minus legs squared, square rooted, right? So what's the cotangent? It wants the cotangent. Cotangent is adjacent over opposite, so it's that mess over what? Okay. They're not always going to use 1. I don't think it's a 1 on the quiz. I don't know if we have some more examples. Did I just do those two? Are those the two I just did, though? They're just numbered on yours. Okay. No, they're not. The first one is. The first one is the same, but this one is different. A little bit, right? Sine x over 1. Okay. So hypotenuse squared equals leg squared plus mystery leg squared. If I subtract this and square root, I get this, right? Now what's the tangent? Not the cotangent, the tangent. It's opposite over adjacent, so it's this. Make sure it's one of vomit. Because then we have to do this. So I get x square roots of 1 minus x squared all over what? Okay. I like the cotangent better. All right, do you have more of these? You have this little spot, right? Okay. This is just practice. Using your unit circle, where is the sign? Square root of 3 over 2 that is colored correctly for arc sine? I'm thinking up here at pi over 3, yes? Guys, this means nothing if you're not following along on the unit circle. Okay, arc tangent -1. Remember, tangent is the one that is not on here. You have to try them, right? If arc tangent, I'm in the red quadrants. If it's negative, I must be down here, yes? And I can't call these like 7 pi over 4, 11 pi over 6. I got to call them by these negative names. This would have a tangent of -1 over square root of 3, which would rationalize. What would this one have a tangent of? Y over x would be -1, yes? What would this tangent be down here if I put the y over the x? This would be negative square root of 3 over 1, right? This would be -1. This would be -1 over square root of 3, which would rationalize. Okay, so what's the answer to this question? Yes, negative pi over 4. Good job. Okay, they gave us a decimal. Where's the cosine negative 0.5? Okay, cosine, arc cosine is negative in which quadrants? Cosine is 1 and 2. It's negative in 2. I'm looking for a negative 0.5 in the cosine spot, so I get what? 2 pi over 3? If you're not getting this, please holler so we can go back over it. Okay, tangent, positive square root of 3. Okay, tangent is positive in quadrant 1. Okay, so one of these spots, when I put the y over the x, I get square root of 3. Which one is it? Pi over 3? Okay. This says, where is the cosine 1? Positive 1. The x value is positive 1 at 0. And then it says, what is the sine at that same spot? Let's look at the, okay. So it wants to know where is the cosine 1 right there. And then it wants to know what is the sine at that spot. So it's 0. What about this one? What is that? What is, no, we could draw it. Maybe, is it not possible? Let's think about this. Okay, cosine should be what? Adjacent over hypotenuse. Is square root of 3 bigger than 1? Yeah. So this is not a unit circle question, but does anybody know what's going to happen? We drew it. There's the cosine, and now this is the angle, and now it wants the cosine. So you would just get this again when you went backwards and found the cosine, which would rationalize to what? Yep. I swear that's not on the quiz. Okay. What about G? The thing on F was these canceled each other out, right? In the first quadrant, that will always happen. The other quadrants, it doesn't always happen. Okay. What about here? Got to draw, yes? Quadrant 1, because it's a positive. Where do I put the 5 and the 12? 5 is on the y, or the opposite, and 12 is on the hypotenuse. I don't think that's a special triangle. I think they tricked me. I wanted to put a 13 on there, but 5, 12, 13 is a triple, but that's not what this is. Okay, so I have x squared plus 5 squared equals 12 squared, which would be 144 minus 25 is what? 129? 119? So square root of 119 goes here. And we want the what of that triangle? Cosine, which is adjacent over hypotenuse, so square root of 119 over 12. All right, one more. This just means it's in quadrant 1, guys. Okay, where this is greater than 0. And I'm not going to give you one that's anywhere else when it's got variables, I don't think. All right, so this is in quadrant 1. Where am I going to put the x and where am I going to put the 5? It's sine. So it's opposite over hypotenuse, even though it's an x. That's just evil. You should use n or something if you're not going to put it on the x-axis. Now, how do I find this question mark expression? Question mark squared plus x squared equals 5 squared. 5 squared minus x squared equals question mark squared. Now what? Okay, when I square root, does it simplify? No, never. What does it simplify a little bit to? You could write it as 25 minus x squared. Okay, what's the cosine? Yes, adjacent over hypotenuse. All right. Worksheet 22 is assigned, as are the questions on 41 through 46 in the book. I have you have a homework check due tomorrow. Okay. Page 288 is assigned. These are the ones that are the 41 through something. Shall we do a couple of these together since you're having so much fun with these? Which ones do you have to do? 41 through 46 all, right? Okay. Okay, somebody pick one. Okay, 44. The sine is x over 1, right? Opposite and hypotenuse. What's going to go here then? That's not the expression every time, by the way. Okay, so now it wants the cosine of that, which is adjacent over hypotenuse. Okay, 45 says it's the same triangle, isn't it? 45 arc sine is x. Isn't that the same thing? It's the same triangle as 44. So 45, we want the cosecant, which is hypotenuse over cosecant is 1 over sine, so it's hypotenuse over opposite, which is going to be what? 1 over x. Okay. Number 46 is the same triangle. Okay. 46 is the same triangle, and it wants the secant, which is hypotenuse over adjacent. Ick. 1 over this mess will become what? All right, the first three are a different triangle. Let's draw the different triangle and get those three done. If anybody watches the video, they'll have their book work done because I'm still recording. Okay, how do I label it for all of these arc cosine ones? The x goes adjacent over hypotenuse. So this would be still hypotenuse squared minus leg squared equals other leg squared, right? Okay, so now you should be able to answer those three. 41, 42, and 43. Yes. On the worksheet 22, there are some of these towards the end here. For example, okay, guys, look at this one. This is lovely. This is on worksheet 22, B. If the tangent is 4x, opposite over adjacent, right? Okay, what happens when you square that disaster and find the hypotenuse? Oh, I already did the triangle for you? That was too nice of me. Do you get it, where it came from? Because it's the hypotenuse, right? This one has a 2x here and a 1 here, so this is going to be what? Anybody tell me what goes here? Yes, but what's 4x squared? Yep. Okay, so the one on the quiz might look like this one. Cosine is adjacent over, so what goes here? Five squared, which is, all right, homework check tomorrow.